Welcome everyone to the last session of the conference. I close things out. Welcome. My name is Ken Jones. I'm a senior instructor with Americana. We specialize in open source training, including Android. And so what I'm going to present here is a session on fragments. It's kind of a continuation of this honeycomb-ish type of set of topics. You learned about the action bar the last session if you were here. And so now I'm going to tell you what in the world these fragments are and how to use them. Now, you may probably have already heard a little bit about fragments. In case you haven't, what exactly is a fragment? Well, it's a class that implements a portion of an activity. So it's going to either represent some portion of the interface or some type of operation that we want the activity to be performing. Now, the rationale for fragments is to provide more modular activity design. As Android was rolled out to tablets, the layouts that used to work fine for a little handset wouldn't necessarily look good as they scaled up to full tablet size. You have a lot of unused space. Well, the resource system has been around for a long time to be able to provide alternate sets of layouts depending upon screen size and orientation, but if we put a lot more things on the activity, that means that we need to hook up more behaviors to them as well. So, that was the challenge that was being faced. And so that's why fragments were introduced, so that we can have a class encapsulating both a portion of the layout and the behavior that we want for that layout. And then an activity will be able to compose itself of whatever fragments are appropriate for the screen size and the resolution that we have. So as I was implying there, the fragments that we create must be embedded in activities. They cannot run as any standalone entities. So it's not as though you're ever going to see a fragment just kind of flying around on the screen by itself. Most fragments will define their own layouts of views that will just become incorporated into the overall activity view hierarchy, but that's not required. Turns out we can have a fragment that has no layout whatsoever. It turns out to be a rather useful technique to have. I'll show you some examples as to why we might want to do that later on. Now, if you've done any type of Android programming, you're probably quite familiar with the life cycle of the activity class and the different life cycle methods that are invoked. Well, because a fragment lives inside of an activity, it's going to have its own life cycle as well. So we're going to see how the life cycle of a fragment mirrors that of the activity that is contained within it. Now, in terms of actually creating the activity that then uses the fragment, we'll see that there's two different approaches we can use. One is that the fragment can be what I think of as a static part of the activity. It's created as soon as the activity is created, and it's always there in the activity. But we also have the capability of instantiating fragments at runtime and adding them to an activity and then dynamically managing these fragments for interesting effects as well. So I'll show you both techniques for fragment management. So you want to do fragments. Well, if you're programming in Honeycomb or later, there's a set of classes, and the primary ones that we're dealing with are shown here on the screen. Fragment is going to be our base class from which we derive all of our fragment subclasses, all of our specific implementations thereof. Fragment Manager we'll be using to interact with the fragment objects that are part of our activity, and then we'll talk about the purpose of the Fragment Transaction class and how it allows us to perform an atomic set of operations on a collection of fragments in our activity. Now, these were introduced in Honeycomb in API 11. So if you know that your target is going to be Honeycomb or later, you can use these directly. But what if you're trying to be compatible with older versions? You want your application to run in Gingerbread or Froyo or even earlier like Eclair? Well, that's where the Compatibility Package comes into play. Compatibility Package provided by Google is a Java library that we can incorporate in our application, and it implements support for fragments and other Honeycomb features, loaders being the most significant of those, and it does so in a way that's compatible all the way back to Donut, to version 1.6. So each of the classes that are used for manipulating fragments that are part of the standard Honeycomb API and later are going to be reflected in this compatibility package. And they work pretty much the same as their counterparts in the latest Android platform. So for more detailed documentation of all these classes and methods, from the compatibility package, you can reference that. Now, when you download the compatibility package, you can also use JavaDoc to generate documentation of those classes if you want to do that as well. So one thing to make note is that if you are using the compatibility package and you're making use of some of these compatibility classes that are listed down here below, those look rather familiar, but notice that the package names are different here. Those are what you're going to be stuck with. It's not as though these packages are smart enough to try to determine, well, what version of the API does the actual device have? Am I running on Honeycomb? And if so, switch over to the native implementations on the system, so to speak. So if you are using the compatibility package, that's what your application is going to be run against, no matter what version the actual device is actually running. Now that means that as new features get added to the APIs, Ice Cream Sandwich comes out and adds new classes and new methods to the Fragment capabilities. If you're using the compatibility package, you're not going to get them, even if you run on Ice Cream Sandwich. So just be aware of that. And of course, if any bugs are detected and are fixed in the mainline release, it might be a bit of a lag before those are reflected in the compatibility package. You'd have to download the new version of the compatibility package and rebuild your application against that. As you can see, the three primary classes, Fragment, Fragment Manager, and Fragment Transaction, are going to be present in the compatibility package. There's also one that we're going to have to use that is unique to the compatibility package. It's called Fragment Activity. You must use Fragment Activity as the base class for all of your activities that are going to be using the Fragment capabilities, as well as loaders if you're going to be using loaders in your activities as well. So that's one of those things that's really easy to forget, particularly if you're taking an existing code and you are retrofitting it to use Fragments. It's really easy to forget to change your base class for your activity. There's also the issue of, well, that's fine for just a standard activity, but what if you're using preference activity as a base class, or list activity, one of those nice little convenience ones there? Well, we'll see that there's something in store for us that we'll be able to use instead. But we still have to use Fragment Activity as our base class if we're using the compatibility package. To download this, you can use the SDK Manager. It's part of the standard Android open source repository. You just grab that and install it. Once you've got it on your development system, you then need to add the jar file from the compatibility package into your project and then include it in your project's build path. Now, you can certainly do that by hand. Go to your SDK folder, look in the extras folder, find the jar file for it, copy it in there, and then update your build path. But in the latest versions of the Eclipse ADT plugin, there's a nice little convenience. You can just do a right-click, bring up the context-sensitive menu for your project, and then near the bottom there's a set of Android tools, and there's Add Compatibility Library there. Now, when you do that, if you've ever tried this before, you notice it actually goes out and fetches the compatibility library live from the site. So it's always going to try to fetch the latest and greatest version and install that. So if you don't have network connectivity, that might fail. Okay, so before we get into actually creating any fragments, let's take a look at the fragment lifecycle. So just like our activity class and most of the other application components, they're based upon the template method design pattern. Fragment base class follows the same type of pattern. There are a few dozen methods that are defined on the fragment base class. And so for us to implement our own fragment, we'll subclass fragment and override the ones that make sense for us that we need to implement customized behavior. Now, the most important methods to keep in mind are going to be those related to the life cycle of the fragment. And these are very similar to the lifecycle methods that we see for an activity. In fact, 6 of the 7 basic activity lifecycle methods are also present on Fragment. The only one that's missing is on restart. And Fragment does not have an on restart method. Now, the Fragment implementation, the purpose of all these lifecycle methods are very similar. There is a slight difference that we'll discuss in just a moment, but for the most part, if you know what you typically do in a non-start or a non-resume in an activity, you know what you need to do in a fragment as well. The fragment supplements this list of lifecycle methods with 5 additional ones. I think I counted this correctly. And so those are mentioned down here at the bottom. The first one that's invoked in the lifecycle of a fragment is on attach. And this is notifying the fragment after it's been instantiated that it's just been attached to an activity. And the fragment will get a reference to the activity it's now hosted in as its only argument. After the onAttach, then the onCreate method of the fragment is invoked. This is our chance to initialize our fragment. And then onCreateView. And so that's where we're supposed to actually create the view hierarchy for our fragment. So with the fragment, the overall fragment initialization and the visual view initialization are separated out into two separate methods. So that's something else that you might have to adapt existing code to if you're taking existing activities and transmogrify them into fragments. How many people have transmogrified anything? Okay. So that's our onCreate. Then after our onCreate view, the system is going to invoke onActivityCreated. And this is letting the fragment know that its host activity has now been completely created. So this will be invoked only once the activity's onCreate method has returned. So if we need to hook into that, that's our point there. Okay, at this point, we're now into familiar territory. OnStart will be invoked when the fragment is becoming invisible, onResume when the host activity is becoming the foreground activity, onPause when it's no longer the foreground activity, onStop when it's no longer visible, and then we get a difference again. Rather than just a straightforward destruction, there's an onDestroyView method where we're supposed to tear down the view that we created in our onCreateView. Now that's normally done for us automatically, but if there's any additional type of cleanup that we need to do for a fragment, we could override it and do it then. Then we have our onDestroy, and then finally there's an onDetach method letting the fragment know it is no longer attached to a host activity. And once that method returns, then the fragment object will be marked for garbage collection. So, one of the things that isn't in the documentation is that for all of these lifecycle methods, except for onCreateView, you have to invoke the superclass version of the method if you override it. So if you're providing your own custom implementation of onStart, onPause, onDetach, or anything else, you must invoke the superclass version of that method. If you don't, it throws an exception. I wish the documentation told us that, but it doesn't. Found that out the hard way. The only exception is onCreateView. So we don't need to invoke the base class version of onCreateView. There's really no point to it. It's a do nothing, no op stub method. That's all it is. At least that's what it is in the compatibility library. I'm assuming that's what it is in the formal Honeycomb source, though I've not been privileged to see that. Okay, so if you're going to be creating your own fragment, you're going to have to create your own subclass of the fragment base class. And so, typically, you're going to implement some sort of onCreate method. You will have an onCreate view if you want to have a visual interface for the fragment. Like I said, that's optional. You might not need that, in which case you don't need to override that method. And then you would use the other methods in the way you normally would. OnResume, you'd probably allocate expensive resources that might cost a lot of battery life or a monetary cost, and then you would release those type of resources in your onPause. Okay, so let's say that we want a visual interface to our fragment. Well, we're going to have to create some sort of fragment layout. That's going to be taking place in our onCreateView callback method, so we're going to have to implement that. Now, the return value of onCreateView is going to be the root view of the fragment's view hierarchy. So somehow we're going to have to create that view hierarchy. Now, we have the same options that we do when we're creating a view hierarchy for an activity. We can either do it programmatically, where we create all the objects by hand in Java code and set up all their properties and hook them all together, or we can do the declarative approach, where we create an XML layout file and then inflate that layout. And of course, that's usually the simplest way to do it, and I'm a lazy programmer, so I'll take the simplest way whenever possible. Now, because that is the most common pattern that we see, the designers of the onCreateView method went ahead and are supplying this with a layout inflator as one of the arguments that are passed into onCreateView, also passing in the reference to the view group that is going to serve as the parent of our fragment. And who knows, that might be a linear layout or a relative layout or whatever type of layout the activity is allocated to host its fragments. So here's an example where it's just a typical layout file that put together for a fragment. You can see that we have a root geometry manager. In this case, I used a linear layout because it was a rather simple layout. Put together just a few components in there, text view, text, and button. Nothing here that is in any way different from what you'd do to create a layout for an activity. It's just going to be one part of an overall activities layout. So now that we've got our class, oops, did I miss something? Yes, I did. I missed the Java code. So I was just showing you how you'd actually inflate that in the onCreateView method. Let me unmagnify that a little bit so we can better see all this. So just focusing on the onCreateView, we're using the inflator parameter that was passed into us, and we're invoking its inflate operation. The first argument is the resource ID of the layout that we need to inflate. So here's just a resource file that I created for my fragments layout. The second argument is the view group that's going to serve as the parent. Well, that was passed in as the second parameter to the onCreateView. And then the third parameter, argument that we want to provide to the inflate operation is false. We're saying that we want the inflator to inflate our layout but not attach the layout to the parent container. Now that seems odd at first because you say, well, don't we want our layout hooked into the parent? Isn't that the whole point of it? Well, yes, it is. However, the system's going to do that for us automatically. When we return our view, the root of our layout hierarchy from onCreateView, the system is automatically going to attach it to the parent layout at the appropriate point in time. So if we provide a value of true here, it's going to be tried to hook up twice. So it's not going to be very successful. So you always put a false in. Now at this point we could do any of the rest of our UI setup that we needed to do. For example, if we need to install listeners on buttons or other types of objects, we could do so. So here I'm showing an example of just using the fragment itself as the listener for the button click operation. So just as you might do with an activity and overload it with additional responsibility, such as listening to button clicks, we can do the same thing with the fragments that we create as well. Yes? Well, for a fragment, I cannot think of any case where we would ever provide true here. I mean, the layout inflator is a general purpose class in Android. So it's what's used in general. In an activity, when you do a set content view, it's actually responsible for parsing the XML if you provided a layout and doing all the inflation and then attaching it to the root view of the entire window itself. So because it is a general purpose, it does have that parameter where you can choose true or false. But for a fragment, we always want to use false to defer that to the system itself. Okay, so what next? Well, we've got our fragment now defined. We've created the fragment class. We've got our layout. We just need to put it into an activity somewhere. So the easiest way to use the fragment is to statically include it into an activity layout. So let's say that we've got an activity layout file. Well, we can actually use this element called fragment. And yes, that really is lowercase f fragment to just indicate where in the activity we want this fragment to appear. We want to then specify the Android name attribute and provide the fully package qualified class name of the fragment that we want to include, and then any layout attributes to control the size and positioning of the fragment within the activity's layout. Now, every fragment that we create has to have a unique identifier so that we can get access to it programmatically. And there's a couple of different ways we can do so. One is that we can supply a unique Android ID attribute here in the layout to identify it. Another possibility is to provide an Android tag, which is just an arbitrary string that we assign, and we'd be able to do lookups on the fragment at runtime using that. Now, if you fail to do either of these in this approach, this static inclusion of a fragment, it's going to try to use the ID of the fragment's container, its root view of its hierarchy. But you really should use one of these ways of uniquely identifying your fragments when you insert it. So here's an example of an activity layout where we decided to include a couple of fragments. You can see we use the fully qualified class name and then any type of layout parameters that we'd like to use. Okay, so that's static, and that's it. Now, let's talk about the fun stuff, the interesting things, where we want to dynamically create and add fragments to our activity at runtime, be able to swap these things out and do dynamic behavior. Now, the first step in doing that is to get a reference to the Fragment Manager. Now, the way you do so depends upon whether you're using the Honeycomb APIs or the Compatibility Package. In the Honeycomb APIs, the activity class has get Fragment Manager, and it returns a reference to the Fragment Manager. On the other hand, if you are using the Compatibility Package, the Fragment activity has a get support Fragment Manager that you have to use. It's really easy to make that mistake to call the wrong method call there. I've done that several times there, so make sure you're using the right one. Okay, so now that we've got our reference to the Fragment Manager, we need to begin a fragment transaction. Even if there's only one thing we're going to be doing on one fragment, we still need to start a transaction. And we do that by invoking the begin transaction method on the Fragment Manager. And this is going to return a reference, an instance of a fragment transaction object. Okay, so now we got our transaction object, we're ready to go. So if we haven't done so already, it's time to instantiate an instance of our fragment. We just invoke its constructor, new, my custom fragment, or whatever it is. We got that. And then on the fragment transaction, we're going to invoke this add operation. And we need to specify the view group that is going to be a parent of the fragment, and we do so by specifying its ID. Now, optionally, we can also provide a string tag to identify the fragment as well. Now, once we've executed the add, then we need to commit the transaction by executing the commit method on that fragment transaction. So putting it all together, this is what it's going to look like. Getting our Fragment Manager, whichever way is appropriate, the Honeycomb API or the Compatibility Package. There we're getting our fragment transaction, we got our fragment, we add it, we commit it. Sounds simple. If only it were that simple. There is a catch. And it has to do with turning the device sideways. Runtime configuration changes. You know, if you've done any type of Android programming, you know in a runtime configuration change, the system bounces the activity. It destroys the activity and then it recreates the activity so it can refresh itself with all the new configuration options, any new resources it needs to load up in the new configuration. Well, once a fragment has been added to an activity, if the activity gets bounced, if it gets destroyed and recreated because of a runtime reconstruction, configuration change like that, the fragment gets automatically recreated as well. Automatically, which is great, unless you weren't planning for that, because if you happen to have like this code here creating and adding a fragment in your onCreate method of the activity, and you just always do it, well, now you've got the old version of the fragment that got recreated and this new one that you're adding in as well. And that's another one of these things that not really documented very well. You find it out the hard way when your applications break. So what do? Well, you need to figure out, are we getting recreated because of a configuration change, or is this the first time through? And the way we can do that is in our activity, check bundle. That bundle is going to contain all of the runtime configuration of the old activity that is being recreated. Now, if this is the first time the activity has been created, that bundle argument is going to be null. And so that's your signal, I need to create all my fragments from scratch. If that bundle argument is not null, we are recreating the activity because of configuration change, and that means that we should not recreate any dynamic fragments. They are already being recreated for us. So it's a simple test. Here's an example of doing it in the onCreate where we just check that bundle that we get in our activities onCreate. If it's not null, then we do our dynamic fragment initialization and adding. Otherwise, we skip this step. Okay. Now, what about saving a fragment state? The whole idea of a runtime configuration, well, what if there's additional state information that I need to save? Well, in an activity, there's the onSaveInstanceState method. It's invoked automatically by the system when it needs to save the state of the activity, usually because of a configuration change, and it's provided with a bundle. Well, the Fragment class has an onSaveInstanceState method as well, and it works pretty much the same way as the activity class. The fragment is going to automatically crawl its view hierarchy. Any views in the hierarchy that have IDs, it's going to invoke their onSaveInstanceState methods, which will save whatever dynamic state those views have, and then as the system recreates the fragment, it will use that information to resuscitate my fragment in the state that it was previously. Now, if I have some additional information that wouldn't normally be taken care of by this default behavior, I have the option of overriding the onSave instance state in my fragment. And then I'll just be putting it into a bundle, just like you would in an activity, and then I would use the values from the bundle in my onCreate view, or my onActivityCreated method. Those are the three objects that the bundle is provided to. Now, there is one difference here versus an activity. A fragment does not have an onRestore instance state method, so you can't override that in a fragment the way you could in an activity. Now, if you've done any work with activities and you've had to save state information of an activity because of configuration change, you know sometimes that this bundle isn't enough. You've got some heavyweight object that you want to retain across instances. You know, you bring the activity down, bring it back up. You say, wait a minute, I got a lot of data that I pulled off the internet, or you take a lot of calculation to come up with. I don't want to recreate all that from scratch. And so the activity has a technique where we can say, oh, we'd like to have the system hang on to this object for us and then give it back to us once the activity has been recreated. You know, it's not all that obvious to do. It's kind of clunky, and if there's multiple pieces of information you want to retain, well, it's not an insurmountable problem. It's just bothersome. Turns out that with fragments, it's a lot easier. The fragment class has a method called setRetaininstance. It just takes a Boolean value, and if you give it a Boolean value of true, you're asking the system to automatically retain this fragment object in memory as the activity goes down and gets recreated. And so it's not as though it's getting destroyed and recreated in the same state. It is hanging around in memory, retaining all of its state information. And we can do this for as many fragments as we like. So if we got 3 or 4 fragments, we could set retain instance to true on all of them if they all have important information that I don't want to recreate from scratch. Now, when you set retain instance state to true, then what's going to happen is that when the activity is going to be recreated, the fragment's onDestroy method will not be called, and then its onCreate method will not be called either. And then the fragment will be retained in memory. But all the other fragment lifecycle methods are invoked in the typical sequence. Now, one thing that I did get burned by when I was experimenting with this and learning more about fragments is that if you use the setRetaininstance to true, then the bundle passed to the fragments onCreate view and onActivityCreated is always going to be null. Now, I've done logging, and I've determined that what's it called? I've already forgotten the name of it. The save instance state method still gets called, so I thought it was storing information in the bundle, but no, that bundle just is ignored. It's not returned to my fragment when the fragment is being invoked through all these methods. That's because it didn't get destroyed, I assume, is the rationale there. Okay, so this means that we don't really need to use that activity class's onRetainNonConfiguration instance method anymore, which is good because it's impossible to say. Thank goodness for code completion, otherwise I'd never type it correctly. And that's why it has been deprecated as of API 11. In fact, if you are using the compatibility package, you cannot use the activity's onRetainNonConfiguration instance method. In the Fragment Activity class, it's part of the compatibility package, it has been overridden and marked as final. The Fragment Activity is using it for its own internal purposes of retaining these fragments and loaders, and it doesn't want you messing up with that. So if you're using onRetainNonConfiguration instance, that is something that you're going to have to change as you port code to use with fragments. Okay. Now, just an aside here, it's pretty straightforward. What if you want to create a fragment with no layout? Now, why might you do that? Well, maybe you're just creating a fragment because you want to maintain some state information. Or perhaps you wanted to manage a thread or an async task, and you'd like that to be retained across activity bounces. And you'd say, I don't need an actual visual interface, I just want it to store all this information. Okay, well, fragments with no layouts are easy to do. No need to create a layout file. No need to overwrite onCreate view. Well, in that case, how do we actually use these? Well, we're just going to instantiate the fragment object, invoke its constructor, and then we're going to use a fragment transaction add method to add it to the activity. In this case, we use a different version of the add method. We're not going to be adding it to a container. We use a two-argument version where the first argument is just the reference to the fragment being added, and then the second argument is a string, which is the tag that we want to assign to this fragment, so that we could then programmatically access it later on. So this is just an example of how we might go about doing one of these, but it looks the same pretty much as dynamically adding a fragment with a layout. It's just that the add method is slightly changed. I've mentioned that sometimes we might need to go looking up fragments. Well, that's what the Fragment Manager can do for us. It has a couple methods for that. One is find fragment by ID. You just give it the resource ID of the fragment. It returns a reference to the fragment if it's currently existent within the current activity. And there's also the find fragment by tag. Just give it the string tag, and it too will return the fragment reference if it exists, or null if it doesn't exist in the activity currently. Of course, if you're going to be manipulating the same fragment over and over, it's usually best to retain a reference to that fragment and just cache it in some sort of instance field of your activity. Now, so far, the only dynamic fragment operation we've dealt with is the add operation, creating a new one and putting it into an activity. But the fragment transaction class has several other methods that we can invoke as well. In addition to add, there's remove, where it says we are going to be destroying this fragment completely unless we're going to be using the backstack, and I'm going to be telling you about the backstack and its purpose in just a moment. But remove says we want to take that fragment out of the activity. Replace is basically doing a remove and add all at once. You're going to identify a fragment that you want to remove and give it a reference to a fragment you want to add in its place. We also have the ability to hide or show a fragment. This does not destroy the fragment. It does not destroy the fragment's view. It simply toggles the visibility of the root view group of my fragment. That can often be a lighter weight operation. Corresponding show for that. And then in API 13, they added two new ones, Detach and Attach. So you can read up about those. Basically detaching it, destroying its view hierarchy, but retaining the fragment instance. It's not a destroy, it's just detaching it from the view hierarchy. And then attach would reattach a previously detached fragment. Important. Once again, discovered through hard trial and much error. Those static fragments, the ones that you include in an activity layout, you can't do any of this with. You can't go around removing them, replacing them. You can hide and show them, but that's the only thing you can do. You can hide a static fragment, or then you can show it, but you can't remove it, you can't replace it. If you try to do so, your application is going to blow up. Often in unpredictable ways, but sometimes it's very confusing because you do an operation and it looks like the fragment's still on screen. But then you try manipulating the fragment and you get illegal state exceptions or null pointer exceptions or other types of weird behavior. I haven't found this documented anywhere. It's just, kind of that group knowledge that people get through the grapevine like this. Yes? Well, there's some slight overhead in using a fragment versus just putting it all directly in an activity, but overall the overhead is going to be minimal. It's not as though fragment operations are taking place multiple times a second. These are typically fairly infrequent operations, and I've not noticed any significant performance degradation using fragments versus just putting it directly in an activity. It's once again, I'm not done a lot of detailed checking of the memory impact of how much memory does using a static fragment versus how much memory using dynamic fragments. Part of it would just be a number of temporary objects that would be created that would have to be garbage collected at some point. My gut tells me that if I'm using dynamic fragment manipulation, I'm probably creating a lot more temporary objects that will then require garbage collection. Static is simply inflating the view once, and then it's pretty much there. So it's more, yeah. Okay. It is. What I'm afraid I'm going to have to do is take this offline because I have several more slides to do, so we can talk afterwards if you like. Okay, so, so what do you want to do if you want to do some fragment manipulation? Well, first of all, you have to begin a transaction, just like we did when we did a simple add. Then perform any number of fragment operations you want. It can be on any number of fragments. They can actually be in different containers. It doesn't matter. Adds, removes, etc. And then you finally do a commit to apply the transaction to the activity. Just a note here is that you can only commit a transaction prior to the activity saving its state. So technically the commit has to take place before the activity would invoke onSave instance state. The whole point is activity onSave instance state is trying to pickle the state of the activity so it can be resuscitated later on. And if you're trying to do some fragment manipulation, the save state is no longer going to represent the last, state of the activity. So you'll get an exception if you try to do that after the onSave instance state. But this is showing an example of doing some fragment transactions. And for all of these fragment transaction methods, you get a reference back to the original fragment transaction object. So it allows you to do method chaining like this to kind of abbreviate your code if you like to. Now, the fragment manipulation that we do, we have the option of including in a backstack. So if we're working with activities, if I'm in one activity and it launches another, the system is going to remember the task stack, the activities that we're going, activity A, then launch B, and if I do a back button, it would then destroy the top activity and take me back to the previous activity. So what if I've got fragments incorporated in my activity, and I've been doing dynamic behavior? Well, the default behavior is that if I press the back button, it destroys the activity. Doesn't matter how many fragment transactions I might have committed. It just says, boom, that activity's gone. But I do have the option of taking all these fragment transactions and incorporating them into the backstack as well. In my fragment transaction, as I'm doing a manipulation, any type at all, adds, removes, replaces, or anything else, if I do an add to backstack method before doing the commit, that's telling the activity to remember this state. And so then, if I were to do a back button, the user presses the back button, it will go to the previous fragment state before that transaction was committed. And so we could stack up as many transaction states as we like and back. And it's only once we've popped all of the fragment transactions off the stack that pressing the back button again would destroy the activity. Okay, so action bars, option menus. Can fragments play with those too? Why, yes, they can. Yes, they can. So my fragment can say, hey, I've got a set of action bar items, or I've got some option menu items that I want to include. Now, for us to do that, in the fragments onCreate method, the fragment must invoke setHasOptionsMenu. It's telling the activity, hey, look at me, I've got option menu items. Okay, so once we've done that, then in our fragment class, we can provide our own implementation of an onCreate options menu, saying when the option menu is created, here are the items that we want to include in it. And then we would provide an implementation of onOptions items selected so that we could detect if any of the items that we had created had been selected. And then optionally, if we want to, we could also provide implementations for the other option menu manipulation items, like onPrepare, onOptionsClose, and onDestroy. Now, the activity needs to work and play well with this. So if we've got my activity then, what it needs to do in the activity onCreate options menu, for example, it can do its own setup of option items. It can say, I've got 3 that I want to add, but then the activity must invoke its super version, the base class version of the onCreate options menu to say, oh, and now let's go ahead and do the rest of the setup. And so the fragment activity or the activity base class would then look at all the fragments that have registered as having option items and invoke their onCreate options menu. Similarly, in the activities onOptions items selected, it should look for any items that it added and then invoke its base class onOption item selected method so that it can then propagate that call down to the fragment so they can detect if any of their items had been added. Now, what about the dynamic behavior? What if a fragment gets added or removed at runtime? Well, the system takes care of that. fragment gets added that has option items, those get automatically added to the options menu or action bar. If that fragment is hidden or removed, they're automatically taken away. So the action bar always reflects the current state of the visible fragments that are incorporated in the activity. And so just an example of code that would do this. This is an activity. So we're showing that the onCreateOptions menu here is invoking the base class, so it can do the fragment initialization, and then it flates its own menu items in, returns true to indicate go ahead and display the menu. In the onOptions item selected, somebody selected one of those items. So in this case, we're testing the ID of the item selected, looking for any that the activity put in it, and then if it doesn't match any of the activity put in it, we just say let's kick it up to the base class onOptions item selected and let it check all the fragments. The fragments then would have their own implementations. The onCreate to indicate that they have option items, the onCreate options menu to then inflate their items into the menu, and then the selected to check for the ones that they explicitly added in. Yes?
Does it merge activity and fragment menu options?
Yes. So.
Do you get more than 6?
Oh, if you got, well, in that case, then the overflow options menu would be displayed, the full options menu, or similarly the action bar, those would end up in the overflow menu of the action bar. Okay, now we've seen how the activity can create these fragments and how the fragments can contribute option items there and into the menus. What other type of communication can take place? Well, the activity created the fragment. It's got a reference to the fragment. So basically, any public method on that fragment is fair game. So it can directly access those public methods, no problem. If you didn't retain a reference to the fragment, you could always look it up with the Fragment Manager using find fragment by ID or find fragment by tag. What about the other way? Well, the fragment class has a getActivity method, which will return a reference to the hosting activity. And then I could invoke any public methods on my activity that I'm contained within. For example, I could say, hey, I'm in a fragment here, and I want to go up to my activity, and I want to go explore its view hierarchy, find view by ID, and manipulate the things directly. Anything public, I would have access to. But you probably don't want to do that. And so I'll tell you a best practice approach to that in just a moment. I do want to make one comment here, though, once we're talking about interacting with the environment, is that the fragment class is not derived from the context-based class. A fragment is not a context. And so if you need a context for anything within your fragment, you're going to have to obtain it. You could either just use the activity object, use getActivity and use it as a context, or through the activity, you could invoke getApplicationContext to get the application object as a context. And so particularly for anything that's going to hold on to a reference to a context for a long period of time, you're probably going to want to get the getApplicationContext. You don't want to hold a reference to an activity that the system is trying to destroy. So don't hold a context longer than you need it. Okay, so some best practices here. One, design for loose coupling. And this is one place where I think that the examples on the Google site really are bad. If you take a look at, you've got this article selector fragment and an article viewer fragment, and you've got the article selector that's asking the activity, hey, activity, I need to check the container that you've got over there. Does it actually have the other fragment visible? And that is really tightly coupling this fragment with the way it's going to be used. What if you wanted to reuse this fragment as a standalone fragment in another activity? Well, suddenly all of that introspection of its environment doesn't apply anymore. So you really want to be careful about making your fragment too aware of its hosting activity, because then that's going to greatly reduce the amount of reuse. Now, on the other hand, it's kind of difficult to avoid the other way. I mean, the activity has to have certain knowledge of the fragment to interact with that. So that's okay because you're usually designing the activity knowing the capabilities of a fragment. You're saying the activity needs to do this, and the fragment is a core component of that. So that tends not to be the big issue. The big issue is tight coupling of the fragment to its hosting activity. So one of the best ways to avoid this, Java interfaces. You define callbacks. So you say, okay, this fragment is going to have a set of callbacks as defined by an interface that it provides. And so then we can register a listener to detect these events going on in the fragment. So we could either have the hosting activity implement the interface if you want, or you could provide a registration method on the fragment where we could register any listener object as long as it implements the appropriate Java interface. So here's an example where creating a fragment definition here, and what we're saying is that we're going to declare a nested interface called onTitleSelectedListener, and say there's only one callback method called onTitleSelected. So if you want to be a listener, this is the method you have to implement. Now, if we decide that we're always going to require the activity to implement the interface, well, we could go ahead and check for that in the onAttach method of the fragment. As the fragment is attached to the activity, we could then just try to do an assignment, try to take this activity, cast it to the listener type. If that throws a class cast exception, hey, you're trying to put me in an activity that doesn't know how to listen to me. And so you're just going to bomb out at that point. But as long as the cast is successful, now we've got a listener. And so as something interesting occurs in my fragment, I can then just go to the listener and invoke the callback method that registered. And so there's just activity source code showing you the implementation. How are we doing on time? I'm assuming I'm pretty much out. I can't tell where I am. Oh, gee, 4:05. How'd that happen? Okay, so then this gets to the other best practice I was going to point out. Using the activity as, I call it a switchboard. So just basically saying the activity is where you should have the communication. So the fragment doesn't know, am I in an activity with another fragment that I work and play with? Is that other fragment hosted in another activity? It shouldn't care. It's the activity that should know how to glue everything together. And so through the callbacks that a fragment could invoke, the activity could then determine, oh, this fragment has indicated something has occurred. I know that the activity, am hosting a companion fragment. I will just invoke the proper methods on that companion fragment to invoke its behavior. But if we've had to refactor it for a smaller screen where both fragments wouldn't fit into the same activity, well, in that case, we'd write the logic in my activity to say, well, in that case, I'm going to have to start another activity where I know it's hosting that other fragment. So don't make the fragments have to go and figure out where these are. Put that logic in the activity. I'll make those fragments more reusable. Because keep in mind, fragments don't have intent filters. They can't detect intents going on. Activities can. So that's another thing to keep in mind. So that pretty much exhausts the time. There's a few other things here I'm not going to have time to get into. If you're interested, the PDF that's available on the conference site will talk a little bit more about implementing dialogues using fragments and talking about a few other specialty fragments. The list fragment, which is a predefined fragment that hosts a list view. It's kind of like the analogy of a list activity. A preference fragment, which sets up a preference screen for you. Point it at an XML preference resource, and it'll create the preference screen and all the editors for it. So it's the analog of the preference activity. And there's also a special web view fragment that is a fragment that's got a pre-built web view setting in it. Just a convenience there as well. So that's it then. I'm going to be hanging out if there's any questions afterwards. But at this point, thank you all.